Pandas is the most important library for data analysis and Python, which we started exploring in our previous video where we started learning Pandas series. In this video, we are going to talk about Pandas DataFrame and learn about a lot of functionalities that Pandas DataFrame can provide to us. Welcome back to the Awesome Data YouTube channel, where you will find awesome things about data analytics and data science. So if you are new to this channel, make sure you subscribe to the channel and give a thumbs up to this video, and make sure you leave your comments below. As we have already started exploring Pandas library, let's talk about Pandas DataFrame in this video. So without any further ado, let's begin. So first thing first, let's import Pandas library to this Jupyter notebook by writing import pandas as pd, which we have learned in the previous video, and let's also import NumPy as np. If you do not know NumPy and how it works, it is also a library for data analysis, and we have a dedicated video on NumPy that you can find in this video link. So make sure you go to that link where we have an extensive tutorial on NumPy. Let's get back to the video. So we have imported pandas and NumPy. Let me press Shift Enter and run this cell. Now let's talk about Pandas DataFrame. So let me write a heading, Pandas DataFrame, and let's make it a markdown cell. So now this is Pandas DataFrame. Let me run this cell, and now let's begin from here. What is a Pandas data frame? Let me tell you that Pandas data frame is a two-dimensional data structure like a two-dimensional array or a table that consists of rows and columns. We can use Pandas data frame to import CSV files, to import Excel files, or import any table from SQL database. So here let's first talk about creating a Pandas data frame. There are several methods for creating Pandas data frame, and in this video let's talk about three methods that we can use for creating Pandas data frame. So the first method that we will be using here is creating Pandas data frame from a dictionary. First of all, for example, we have some names of people, and we have a list of names like we have John, Olivia, Larry, and Tim. Similarly, we have a list of ages of these people. For example, John is 20 years old, Olivia is 18 years old, Larry is 30 years old, and that's Tim, not time. Tim is, for example, 22 years old. So we have these lists. Let's create a dictionary out of these two lists. For example, let me say D is equal to name is names, comma, we have another entry for ages, so let me call it age and assign it to the ages list. Now we have constructed this dictionary. Let me display this first. If I run this, we can see that this is a dictionary where we have a key for name consisting of 4 values in this list, and then we have age that has a list of 4 values for ages. So now let's run this cell and create a data frame out of this dictionary. So for creating a data frame, we use pd.dataframe function where we can assign a dictionary to this data frame. For example, I can say that data is equal to D. If I run this, it will give me a data frame that you can see here. It is like a table where it has 2 columns, name column and age column. Before these 2 columns, we see 0, 1, 2, 3, and that is the default index that is assigned by Pandas to this data frame. Of course, we can change the index like we did in the series, but we will leave that for another time. Let's talk about the Pandas data frame for now. What we did here is that we have a list of names that is assigned to a variable names. Then we have a list of ages which is assigned to a variable ages. We created Python dictionary from the names and ages variables, and we assigned those 2 variables to 2 keys of this dictionary, name and age, and then we assigned this dictionary to variable D. We can do that here as well. For example, let me copy this dictionary, and instead of D we can just assign that dictionary directly to this data variable, to this data parameter. We can assign this dictionary to data parameter, and we can run this. it will still give us the same table or the same data frame. Of course, we can assign this data frame to a variable. Currently, we have not assigned it to anything. We are just displaying this, but we can assign it and store it somewhere. For example, I can create a variable by the name of df, that means data frame, and I'm assigning this data frame to this df variable. If somewhere below here I want to see that df, I can just print or display the df variable here, and it will still give me this data frame. Okay, I have not run this cell again. Let me run this, and now if I want to display this and run it again, you will see the same data frame that we saw before. So this was one way of creating a data frame. Let's now talk about the second way, and this method includes the NumPy random module. For example, we can say that let me create a two-dimensional array from NumPy. Let me say np.random.randint. Again, if you do not understand how NumPy works and what random is, what randint is, you may check out this video that is given in the link above, where we have talked about NumPy library and how it is used for data analysis and Python. Remember, that is a big video and we have an extensive tutorial on NumPy in this video. Make sure to check it out. Let's get back to the video. So we have np.random.randint, and I'm using this randint function to give me values between 10 and 80, for example, and I want it to prepare a two-dimensional array for me. That two-dimensional array will have 5 rows and 3 columns. I want NumPy to create this array for me and assign that array to ARR variable. Let me run this. If we run this, it will be executed, and let's now display the ARR variable, and it is giving me this two-dimensional array. You can see it has 5 rows and 3 columns. Now what we want to do is to assign this ARR or array variable to Pandas DataFrame function, and it will give us a data frame. Let's do this now. pd.dataframe, like we did before, and this time to the data variable we will be assigning this array that we created from NumPy. If I press shift enter, it will give me this beautiful data frame that is created out of a NumPy array. We can see that both columns and rows have indexes. We have 3 columns and 5 rows, as we told NumPy to give us a two-dimensional array of 5 rows and 3 columns. So it is giving us that array, and we are assigning that array to data frame function to create a beautiful data frame out of this array. Now let's assign that data frame to a variable df, like we did before for dictionary, that we assigned dictionary to the data frame function, and we created a data frame before. So let's save this, and we will be using this df variable in the later examples as well. Now if I show this df variable, it still gives me the same data frame, but we have indexes instead of the column names. What if I want to give this data frame proper column names? We can do that as well. While creating the data frame, we can assign some names to columns parameter that is provided by the data frame function, and we can say that the first column is named A, the second column should be B, and the third column should be C. If I run this, it will be executed, and now if we display the df again, this time we can see that there are 5 rows with indexes, but there are 3 columns with proper column names that we assigned to this data frame function at the time of creation of this data frame. So we studied 2 ways of creating a data frame in Pandas library. Now let's explore the third one. We understand that each column in the data frame is a series, and I have mentioned this in the previous video. You may check it out. So every column in the data frame is actually a series of the Pandas library, and we can combine multiple series to create one data frame out of them. So first of all, let's create some series. For example, let me create a series for name, and I can say that pd.series, let's assign it a list, and the list will be again John, Olivia, Larry, for example, and Tim. So this is a series of names. Let's series of ages, pd.series, and let's assign list to this 12, 23, 34, and 45. So we have 2 series. Let's create them. They are created now. I ran the cell. Now let's create a data frame out of these two series, and I can say that df is equal to pd.dataframe, and now to this data variable I can assign these series. For example, I can create a dictionary and I can say that name should be this name series that we created in the above cell, comma, age should be the age series that we created in this cell. If I run this, it will give me a data frame, and let's now display the data frame here to see the result. So we have this data frame that is created out of two series. So we can create a data frame from Python's dictionary, where each key in the dictionary has a list of values. We can create a data frame from series objects, and we can create a data frame from NumPy arrays. We explored these three ways for creating data frames. Now let's talk more about data frames instead of creating them. For example, this is the last data frame that we created, and we saved it here in the df variable. There is a function called info, and we can use the info function on df data frame to give us some details about this data frame. Let's call the info function, and if I run this, you can see that it says that the type of this df is pandas.core.frame.dataframe. It means it is a data frame object. It has a range index. That means at the beginning of this data frame we have an index, and that index contains a range from 0 to 3. There are 4 values, and we have 0 to 3 indexes in that data frame. Now it says that there are 2 columns. One column is name, another is age, and they both have 4 non-null values. It means there are no null values. The name column is of object type because it stores strings, and the age column is of int64 type because it stores integer values. Now at the end you can see that it is giving me memory usage. It means that this data frame, the df data frame, is actually 196 plus bytes. So this is the memory that is being allocated to this data frame. Now let's make some changes in this data frame. For example, let me copy these values and let me repeat them. For example, twice and thrice. Then let's copy these age values. Let me break the line here so we can see all the values. Let me copy these ones and paste them 2 more times. So let me run this cell, then let me run this cell. Now we can see that this is now a big data frame which has 12 records, and it has 2 columns, name and age. Now let's run the info function again on this. If I run this, we can see that name and age have 12 non-null values. Now it again says that the memory usage is 324 plus bytes. We can use the memory usage as a parameter to this info function. I can say that memory underscore usage should be equal to deep, and if I run this, this means that give me an exact memory that is used by this data frame. And if I run this, now it says that this data frame actually uses 966 bytes. Instead of telling me 300 plus bytes, now it is giving me the exact memory that is used by this data frame. So this is what the memory usage parameter does here. If we assign deep to this memory usage, it gives us a deep memory usage or an accurate memory usage of that data frame. Now that we understand how to create data frames, most of the times we will not be creating data frames manually, but instead we will be importing a table or a spreadsheet from a file. So let's do that. Let's read a CSV file in the Pandas library. So as you can see, I have this data.csv file, and this is the path of this. Let me copy this path from here, and let's go to this Jupyter notebook. We want to read that CSV file and bring the content here. So what we can say that data frame is equal to pandas.readcsv. This is a function provided by Pandas library. We need to pass the path here. Control V. I copied this path from that folder. Backslash. Let me write the name of the file, which is data.csv. If I run this, it will throw an error because this path is not acceptable to the read CSV function. What we can do is to write an R before this double quotes, which will tell read CSV that this is a raw path and this is a raw string. And now if I run this cell, now it doesn't complain, but instead it runs the cell and it assigns that data frame to this df variable. Let's display this df variable and see what it gives us. If I press shift enter, now we can see that it is giving me all the content of that file, and we can see that there are several columns: employee ID, department, salary, gender, and customer feedback till the end. And we have multiple rows here. We can see that there are a lot of rows that we cannot read all of them. Most of the times we will not be seeing all the table that is brought here to the data frame. What we can do is to see the top few rows or the bottom few rows from this data frame. So for that we can use two functions. One is df.head. If I run this, it gives me top 5 rows by default, and another is df.tail. If I run that, it gives me 5 rows from the bottom of this data frame. We can of course change the number. For example, if I want to see more rows or less number of rows, I can say n is equal to 3. Do not show 5, I just want to see 3. And if I run this, it will give me 3. And if I say give me 10, it will give me 10 rows from the bottom of this data frame. We can use the same n parameter in the head function, and if I run this, it will give me 10 rows from top of this data frame. We can see it starts from 0 and goes till 9. It means it is giving me 10 rows from the top of the data frame. By default, we can see that Pandas is assigning this index to this data frame, which is brought from data.csv file. What we can do is to change that index and use one of the columns of the data frame as an index. Instead of that 0 to n-1 index, we can use a column. For example, if I show this data frame here, we have a column employee ID, which is starting from 101 and increments by 1 for each record. We can use this employee ID as an index of this data frame. For that, let's use another function, that is df.setIndex, and write the name of the column that we want to set as an index. We can say employee ID. If I run this, it gives me this new data frame where the employee ID is used as an index here, and we do not have that index of 0 to n-1. If I print this df again, we can see that it still uses 0 to n-1 index, and it is not using this employee ID as an index. This is because we just executed this above statement df.setIndex, which gives us a new data frame, but it does not change the existing data frame here. To change the existing data frame by the use of setIndex function, we need to pass it a parameter, that is inPlace is equal to true. By default, the inPlace is set to false. We are now setting it to true, and if I run this statement again, this time that statement is executed successfully, and now employee ID has been set as the index of that data frame. Let's display this data frame again, and now we can see that employee ID is being used as the index of this data frame. So instead of df, let's say df.head. There is another way of setting employee ID as an index, and that is whenever we want to import that file. Here we have another parameter in the read CSV function, and that is index call is equal to employee ID. So what we are saying here, that import this data.csv file from this path, and by default the employee ID should be set as the index column. If I run this here, this statement will be executed, and now if I run this df.head again, we can see that from the beginning the employee ID has been set as the index of this data frame. So we can use these two methods, either by using the setIndex function or by using this index call parameter to set another column of the data frame as its index. Instead of picking the top 5 or bottom 5 records from the data frame by the use of head and tail functions, Pandas library provides another function for picking random 5 or random n number of records from the data frame, and that is sample function. Let's use it here. We can use df.sample, and if I run this, it will give me a sample record from this data frame. It is selecting this record randomly and is displaying it here. We can see that the employee ID here in this sample is 102. If I run this again, now this is 109, and if I keep running it again and again, it will keep changing the record. We may have the same record twice, and that will be a coincidence, but here sample is just returning a random record from this data frame. So it's returning only one record because the n parameter by default is set to 1. If we want to change it to 3, it will give us 3 random records from this data frame, and if we change it to 5, it will give us 5 random records like this. So we use sample function for returning random n number of records from the data frame. There is a parameter in the sample function, that is random state. So for example, I am saying that df.sample random underscore state is equal to 3. If I run this, it will give me this record with employee ID 115. This random state tells this sample function to return the same record whenever random state is equal to 3. If I run this again, it will give me the same record again. If I run it again, it will give me the same record. If I change the random state to 10, it will give me another record that is associated with the random state 10. For example, if I run this, it gives me record with employee ID 108. If I run it again, still 108. If I run it again, it's still 108. But if I go back to random state 3, we will have the previous record that was displayed with employee ID 115 that we saw before. So we use random state parameter in the sample function to give us the same record with the same random state over and over again. There is another parameter in the sample function, that is replace. If we use replace equal to true, then there will be a possibility of returning the same record twice or thrice or multiple times. For example, if I say df.sample, I am saying that give me 8 records, let me assign 8 to n, and I am saying that replace is set to true. It means that there is a possibility of returning the same record multiple times in this result set. If I run this, let's see if it is returning the same record multiple times. 107, 6, 113, 6. We can see that we have 106 here and we have 106 here. So 106 is returned twice by this statement. If we increase the number of records, for example from 8 to 10, and if I run it again, let's check if we have the same records repeated here. 17 twice, so it is returned twice. Then we have 19, so we do not have another 19. We have 18, 16, 6, 101, 110 and 113. If I keep increasing the number of records, for example to 15, and if I press shift enter, let's see if it is returning a record 2 or 3 times. 120, 18, 9, 15, 3, 5, 7, 4, 13, 3. So 103 is returned twice. We have 103 here and we have 103 here as well. Then we have 108. 120 is repeated again. We have 120 over there on top of the result, and we have 120 again. So 120 is repeated 3 times here, and some other records are repeated 2 times. So we use replace parameter to tell sample function that you can repeat a record more than 1 time in this result set. We understand that Pandas data frame has rows and columns. So there are 2 axes in the Pandas data frame. One axis is axis 0, that is row, and another is axis 1, that is columns. We can use the axis property of the data frame to give us both of the axes here. Let's see its usage. For example, I can say df.axis, and if I run this, it gives me this result. First, it returns the indexes of the rows here, which is axis 0, and then it returns the column names, which is axis 1. We can use this axis and we can access axis 0, which will return only the indexes of the rows. So it is returning rows here, and if I say axis 1, it will give me the column names. We can extend this and we can use another subscript, another pair of brackets to access any of these columns. For example, we can say give me department column. If I want to see department only, because this is the first name in this result set, we can use 0 index here, and this will be returned as the result of this statement. If I run this, it says department. If I change it to 1, it will now return the second column, and so on. So we can use 2 pair of brackets to access any column name or access any row index. For example, if I want to see the first row here, I can say 0 0, and if I run this, it says that the index of the first row in this data frame is 101, and if I want to see the second one, I can change 0 to 1, and if I press shift enter, it will return the index of the second row of the data frame. Similarly, instead of using df.axis, we can say df.columns, and this will return all the columns again that we saw before in df.axis 1. So here again we can say that give me columns 0, and it will return department. If I say give me columns 1, it will return salary, which is the second column. Now that we are kind of familiar with data frames, let's now use some functions to extract columns and rows or data from the data frame. So first of all, let's change the index. df.setIndex to department. I am changing this to department for some examples here. If I press shift enter, and let's use in place to true again, because it will not change the data frame if we do not use in place set to true. If I run this, it will run. So now let's use df.setIndex and use department as the new index. Let's use in place parameter as well to bring the changes in this data frame. Let's see the data frame top 5 rows. If I run this, we can see that department is now being used as the index of this data frame. So now that this department is being used as the index, we can use df.lock indexer for fetching data from this data frame. We use df.lock for fetching data based on labels. Because department is label based index, we can use df.lock, and I can say that give me all the records where the department or the index is sales. If I run this, remember that it gives me all the rows where the index is sales. If I change it to finance and I press shift enter, now it will give me all the data, all the rows where the index is finance. So we use the lock indexer on the data frame to fetch data or rows based on a label based index of the data frame. Because I've run df.lock finance, it gives me these 3 rows with all the columns. What if I don't want to see all the columns, but I just want to see one of these columns? For example, I want to see this salary column. I can just use another pair of brackets, and I can mention the salary column here, and if I press shift enter, it gives me a series this time where the department is used as the index and the salary column is the only column that is available in this series. If I check the type of this, for example, I use type function here, you will see that this is returning a series, pandas.core.series. Because salaries is the only column here, and we know that a column in the pandas data frame is a series. So let me remove this type function again. Now what if I don't want only the salary column, but I want to see 2 or 3 columns? So this time what I can do is to, instead of writing this salary in this pair of brackets, we can use another pair of brackets inside this second pair of brackets to list the names of all the columns that we want to see here for the finance index. So we can say that give me salary, comma, give me work hours, and comma, give me meetings attended. oops, let me enclose them in double quotes, meetings attended. If I press shift enter, you can see that it is returning another data frame where the index is finance only, and it is returning the 3 selected columns here in this new data frame. And this time if I check the type of this, it will be a data frame because it is not only one column this time, it has 3 columns. It says Pandas core, frame and data frame. So let me remove the type function. We understand now. We can achieve the same result using only one pair of brackets. For example, I can say df.lock give me finance index, comma, inside the same pair of brackets I can mention the column name, which is salary. So I want to see only the salary columns data for finance index. If I run this, it still returns the same series that we saw before. And if I want to see multiple columns here, again we need to use another pair of brackets, but this time inside this lock pair of brackets here. So after salary, I can say give me salary and work hours. If I press shift enter, it is returning a data frame, but this time we have changed the method. Instead of using another pair of brackets outside this pair of brackets and then preparing a list there, we just use the same list inside this first pair of brackets and it is giving us the same result. So here for the rest of the examples, I changed the index again to employee ID, and now we can see that this data frame is using employee ID as its index. Now for example, I'm using df.lock function. Now I'm using df.lock indexer to see records with employee ID 101. If I say 101 and I press shift enter, now it is giving me this series where we have this data. What if I want to see data from first row till the 5th row? So I can say that give me data from 101. I can use colon and I can say 106. Now if I press shift enter, it is giving me this data frame where we have all the rows from 101 to 106. I used 106 here. If I use 5, it will give me the 5 rows from this data frame. We can use the same method here. For example, I want to see these rows, but I want to select some specific columns. So I can say give me only the salary column. If I press shift enter, it is returning this series this time. And if I want to add more columns, I will enclose this in another pair of brackets, and here in this list we can say give me salary, give me department, and also give me gender. If I press shift enter, it will return this data frame where we have the selected rows and we have the selected columns that we specified in this df.lock indexer. We can also specify a range of columns. For example, let me delete this and let's see this data frame. I can say that give me all the columns from department to work hours. So what I can do is to say that give me department colon give me work hours. Enclose this in this pair of brackets. If I press shift enter, we can see that it is giving me another data frame where we have 5 selected rows and we have a range of columns starting from department till work hours. What if I want to pick selected rows and selected columns? I don't want to select a range of rows, but instead I want to select the first row, then the 5th row, then the 10th row, and similarly I want to pick selected columns. So let's do that as well. Let me run another statement in this cell. For example, df.lock. Let's enclose this in a pair of brackets. Inside this, let's open another pair of brackets and mention a list of rows that I want. For example, I want row number 101, I want row 104, and I want row 110. So I want these 3 rows, comma. Let me open another list, and inside this list I can just write all the columns that I want to fetch. For example, I want to fetch salary column and I want to fetch department. So I want these 2 columns for these 3 records. If I press shift enter, it will return another data frame where we have 3 rows and 2 columns selected from the data frame. Now that we understand how to fetch data based on label based indexes, let's now use iloc indexer to use the range index, which is by default given by the pandas library, and fetch data based on iloc indexer. So first of all, we need to reset the index because employee ID is being used as the current index. So we can use the reset index function on df to reset the index. And if I run this function, let me write in place is equal to true. This will reset the index. If I run df.head this time, we can see that the index has been reset. Now employee ID is not the index, but this 0 to n minus 1 is used as the index here, and this 0 to n minus 1 is a pandas object that is called range index object. Now we can use the iloc indexer on this range index object to fetch specific rows from this data frame. For example, I can say df.iloc and I can say give me record on index 0. If I press shift enter, it will give me a record on index 0, which is 101. You can see from sales department, and this is the entire record. If I change 0 to 3, it will give me the third record where the ID is 104, and we can see index 3 we have 104. We can also use a range here. For example, instead of writing 3 or 0, I can say give me a range of records from 1 to 4. If I press shift enter, it will return a data frame where the first index will be included, but the last one mentioned here will not be included. So this is the general rule in pandas and numpy, where the last mentioned index is not included, but the first from n-1 is included. So we can see that index 1 is included, 2, 3 are included, and 4 is not included. If I want to include 4, I will need to change this to 5, and if I press shift enter, now 4 is also included here. So we can use a range like this, which will give us a range of rows. Similarly, I can pick selected rows. For example, I can say df.iloc. I can open a pair of brackets, and inside this I can use a list, and I can say give me data in index 1, index 4, and index 10. And if I press shift enter, we can see that it is giving me this new data frame where the indexes are 1, 4, and 10 that we selected here. We can use the slicing technique to select rows and columns together. For example, I can say give me df.iloc, give me 1 to 4 rows, comma, give me the 0th column. It means the first column, which will be employee ID. If I press shift enter, we can see that it is giving me 1, 2, 3 for the rows, 4 is not included, and it is giving me the employee ID. And at the end, we can see that the name of this column is employee ID. This is a series and not a data frame. And we can use a range here as well. For example, if I say 1, it will give me the second column, which is department. And if I use a range here, 1 to 4, close the brackets, and if I press shift enter, it is giving me this data frame where we have 1 to 3 rows and we have 3 columns, 1, 2, and 3. Department is at index 1, we can see because index starts from 0, and at 0 we have employee ID. Then we have department at index 1, salary at index 2, and gender at index 3, and we can see the result here. We can use 2 different lists for providing a list of rows and providing a list of columns as well. For example, I can say df.iloc, open and close brackets. Inside this, I can use a list to select a few rows, for example 1, 5, and 7, comma, I can use another list for picking columns. For example, if I want to pick department and salary, I will just say department is at index 1 and salary is at index 2, and also I want to see this tasks completed. So this will be at index 0, 1, 2, 3, 4, 5, at index 5. So let me put a comma and add 5. If I press shift enter, we can see that it is returning 3 rows and 3 columns. By the way, this does not need to be 3 rows and 3 columns. We can just change the number of columns or rows. For example, I want columns at index 8 as well. If I press shift enter, now we have 3 rows and 4 columns. So this is how we fetch data from a data frame using the loc and iloc indexers. And I think this is enough for today, and we will keep going in the next video as well. We will keep talking about data frames and how to filter data, how to fetch data from data frames, and how to actually do the analysis in Pandas library. If you get value from this video, please give it a thumbs up, which helps us a lot. Leave your comments in the comment section. And make sure to join our data analyst communities. I will provide the links in the video description. We have a data analyst community of WhatsApp. We have a data analyst community of LinkedIn as well, where we share books, trainings, internships, tutorials, projects, and so on. If you have any questions, do let me know in the comment section so I can provide answers to your questions. Thanks for watching.